All right. Happy Thursday. No, Wednesday. I don't know what day it is, friends. I'm so out of it this week. 'Cause I was gone Monday. So I forgot the quiz. Sorry. Okay if we just skip it? Okay. It's loops and strings. Like it was not very interesting. Um, ask questions about indexing. Can you do negative ones? Those sorts of silly things. So this week I'll try and remember though. I'll make myself another note here to write the quiz for 98. Um, I, it's surprisingly Notepad is great. It's very easy, and then when you try and shut your computer down, it's like, hey, you have a file open. The dumbest little Notepad program will stop Windows from shutting down. But anyway, so we'll do that because it'd be nice to get those points for you as we go, but don't need to worry about that one. So this week we're going to get into files. We'll have lots of fun with files, reading and writing files. You should have already done text-based files. You might have looked at binary files. I'm gonna show you how to do it, and I'm gonna say it's not worth our time right now. Um, just Python can read and write binary files. Cool, good story. So if you want to do that, great. Most of the time, text files are at least easier for us to read and write, and we don't need to pack things in that kind of a dense format that you would get advantage of. So taking up extra space to store everything as characters, it's not the end of the world, right? Most computers have plenty of storage. We're pretty spoiled. We can just be lazy. I don't need to pack my integers in individual bytes. I can just use the characters, and it wastes some space, but it's okay. It'll be readable for us, and that works out pretty well. Um, we got to finish out the tax calculator project, so I'll show you how I'll go about solving it. It goes pretty quick here. I might skip a few of the brackets because it's the exact same thing over and over and over again. I'll show you a couple fun things that I try here. Um, I don't use the ternary expressions because I hate them. But again, there's a pretty quick, easy thing you can use for ternary expressions if you like those. And ChatGPT loves them. So if you ask ChatGPT to solve this project for you and turn it in, I'm going to see a bunch of those. Uh, that's what it is. I don't think you would have needed any help for this. This was sort of our first, hey, let's write some Python code. And by the way, taxes exist and things like that. So that'll be fun. And then we'll start our next project, which will be due week 5 on the 11th. So we got 2 weeks for that project. We'll be reading and writing files, right? Practicing some of this file stuff. And we're just going to do text files because it's easy. Um, yeah, should be pretty good. Lists, dictionaries, and tuples next week. There's lots of fun things we can do with them, diving a little deeper into the basic data structures in Python. That'll be fun. And then regex and network programs, fantastic. We'll just kind of hit on regex. There's a lot to it. We'll look at a couple of the highlights, but the focus will be on networked programs. Uh, and we might even get into Python and web services. We'll see how far we get that week because that'll be a fun part of the next project. And should be pretty good. Okay. All right. Hope you're all staying warm. So let's pull up our tax calculator project first. Let me fire up PyCharm, and we'll go through this real quick here. If PyCharm will ever load for me. I think I'm due for a new laptop. This has just gotten slower and slower and slower. Maybe just reinstall everything. Usually helps. No, not a notebook. That was the wrong button. New project. There we go. 298. This is project 1. Welcome script, virtual environment, good to go. All right, first thing we needed was get all of their deductions, right, and get all their incomes. And then we'll figure out which one is bigger with the standard deduction for that one here. And then we'll get their adjusted gross income, and then we'll go through the tax brackets. Make my welcome scripts. There it goes. So right off the bat, I'm thinking we're doing the exact same thing here twice. Probably could be a function, right? The only thing that's different is the thing we're asking them, like the prompt, for summing something up here and getting the number back, right? So either write it twice and then be like, oh, I'm dumb for having it twice, and we make a function, or just ahead of time just make the function once, right? So we'll get some value. So we'll define a little function for get totals. And then the only thing that's different then is the prompt, right? So if you tell me what I should ask the user, I can throw that in the prompt here, right? That's going to be what is different each time here. So we'll get the input here. Might be a float. Most people ignore the pennies, I feel like. I don't even know if there's pennies on tax forms. I forget. I just let TurboTax do that stuff. So we'll just assume these are probably integers, right? So we'll have a sum, starts at 0, and then we're going to take that sum and we're going to add to it the int of an input given the prompt, right? Eventually, we'll stop here, right? So maybe this is as long as they haven't entered a specific value. It's probably the easiest way, or we could ask them, do you have more to enter, yes or no? Sure, we can go for that. So more is an input of you have more to enter, y or n, and maybe then we'll start this, more starts at y, and while more equals y, we can keep on doing this whole thing here. Eventually they'll tell us, hey, we're done, right? That's probably okay, right? There's tons of different ways of doing menus. That's not the exciting part here, and we'll keep on going. Now, if we wanted to add a try block to make sure we actually converted this, that might be nice, right? So we don't crash, right? Do we get to try and accept? We did that, right? Yeah, so we could do a try, uh, and then accept. What do we want? That's a value error, I think, is what shows up here. Print invalid number. I don't know, some things we don't crash, right? And sure. And then when we're done, we can return the sum, right? Easy enough. So then our total deductions will equal the get total, given enter your deduction, or enter a deduction, right? A deduction. And then total or gross income, deductions. I can't spell at all. There we go. Gross income then is a get totals of enter and income, right? Get more to enter. Right. Great. Now I've got both of these. Now we're going to need to see was total deductions bigger, right? So if my total deductions is less than the standard, right, that's the 15,750, 15,750, then total deductions can equal 15,750, right? And then I'll have an adjusted gross income. Gross income is my gross income minus the deductions. And then if my adjusted gross income is less than 0, we'll just set adjusted gross income to 0, right? You don't get money back. Technically, there's credits you can get back that are refundable, and then there's credits that are not refundable, and then there's the deductions, and the whole thing's nonsense, but it's what it is. This is what happens when rich people get to write the tax code and give themselves all sorts of loopholes. Thanks for paying your taxes, by the way. It's nice to have loopholes. I'm pretty sure my uncle made it on one of those funny websites where they talk about ridiculous things rich people do, because he's a private pilot, and one of the things he likes to do is fly small planes. And then they lived in Pennsylvania, and they bought a condo in South Carolina. They actually bought two of them, and they rented both of them, but they could go and stay at one to do maintenance on it and maintenance on the other one. And if more than 50% of your trip is business related in terms of your own a rental management company and you had to take care of your units, it's all tax deductible. And he was able to deduct the private plane expenses because they flew a private plane rather than flying commercial. And that made the news of, hey, look what rich people do. They deduct their private plane expense as a business expense. How does that work? I don't know. I didn't write the tax code. And you take advantage of it, right? Um, the whole thing is silly. Anyway, um, now we got those. Now we need to go figure out how much taxes we owe at each bracket, right? So we can go take a look at our brackets. I probably pick the single ones, whichever one you picked is fine here. The formula here, right, is the top of the bracket minus the start of the bracket. And then if your income is more than that, right, you're paying the whole amount. If it's less than that, you just pay that amount, right? So if you made somewhere less than 11,925, you just pay 10% of that. If you made more than that, then you pay 10% of the entire bracket. If you made more than 48,475, you would pay 12% of the top of the bracket minus the start of the bracket at the 12%. Again, these numbers were a little old here, back when brackets were different, but that idea. So that process will be the same. The only thing that's different then is the start of the bracket and the end of the bracket. So you're thinking to yourself, hey, it's another function. I'm glad you thought of that. That's great, right? We don't want to do the same thing more than once. Otherwise, we should feel bad about ourselves. It's a pretty good rule of thumb. And then if I've got a bunch of numbers here and a bunch of numbers here, I could make a list. I could make a list of lists. Tons of different ways of going about it here. You could make a dictionary with an associated value of another list that we haven't really gotten that deep yet here, but all sorts of interesting ways here. Most of the time, ChatGPT gives you a dictionary with a list of lists, because then you can pack in a bunch of other stuff here, and you even know what the bracket is and all sorts of other nonsense. Because why write a class? I mean, we haven't got to classes yet, but why, a class that could store that information with nice variables would be a whole lot cleaner for us to conceptualize and understand and read and write. Well, why not just throw it in a list? Be like, okay, the first thing in the list must be this, the second thing in the list must be this, the third thing in the list must be this, and then you have to remember all those things. And we're adding to our cognitive load. And then next time someone goes to read your code, they're like, who thought of this? What moron did this? Right? It's not clean. So lots of different ways of going about it here. Um, so let's try maybe you want to do a list of lists here and try and keep it a little bit simple, maybe. I don't know how simple that is here, but that's okay. We'll call it brackets then as a list, right? And then inside of that list, then we'll have a start and an end of the bracket, right? Probably okay just to leave it at those two. If we wanted to throw a third thing in, we could throw in the tax rate. But again, that gets to be a little awkward here, or maybe let's make it a little bit clearer. So we'll have start of brackets. Then we'll have two parallel lists, right? We'll have one list for the starts, one list for the ends. That way I put a nice name to them at least. So it's not just here's my brackets and you have to guess at what's the start and what's the end here. Um, that's okay. Right? And again, 7 different ways we can do it. Doesn't really matter here. So 0 is the first one, right? And then 11, 9, 925. And did I show you in Python you can add underscores to ints? It's amazing here. So add in your own digit separators. Just don't put them anywhere because they literally get ignored by Python. So you can do dumb things like that and people will just hate you for your code. Right, and then 48, 475, 475, and then 103, 350, and 197, 300. That's right, I forgot my digit separator. Let's go add those in. Right, 197, and then 250, 525, and 626, 350 here. Okay, so that's the starts here for our brackets, and then our end of brackets. Let's see, should be these numbers, right? Is the start is the end of the next one here. And then the last one is anything up above here, probably like a max int or something. I don't even remember. I think there's a max int here. That looks right. Wow, that's a lot of different max ints here. Int, max int? No. Is that one it? That one might be it. It's a weird library though. I don't know what that one is. Or we could just come up with a big number here. I don't remember Python max int. There's no fixed size here. Oh, great. Sys.max size. Okay, there we go. That's probably better. Use the sys one here. So sys.max size. All right, that should be pretty good there. And I don't know, I bring Python max in. I didn't have that off the top of my head, so maybe that's nice to put in. I don't care if you did one piece here. That's okay. That's not even a line of code. That's like one thing. But it's a good habit. Right? We should try and remember that. Right. Then we need the bracket rates here. So this is the bracket rates. There'll be another list here. So we'll do a bunch of parallel lists here. It'll be a lot of fun, right? So index 0 of the first list, the second list, and the third list kind of all go together, right? So we have 10%. So remember, we don't do percentages, we do decimals, right? So 0.1, 0.12, 0.12, 0.22, 24, 0.32, 3.5, and 3.7. 0.35 and 0.37. 37% is the highest? Ooh, that's sure, that's what it is. All right, used to be higher. All right, now that I have all of those here, we need to go and figure out how much money we owe at each of these brackets here, right? So then we can have money owed at brackets, probably a list, right? And we can start adding to that list here. Lots of different ways. I don't remember how far we got in the list. I think I showed you can append to a list. Okay, good. So that's not brand new here. So we'll go through and see, hey, do we owe money at each of these here? So remember that formula was going to be if our income was more than the top of the bracket, we owe the whole amount. If it wasn't, we owe some of the amount. And if it's less than the start, we owe none of it, right? So we can make a little function here that will calculate all that stuff for us here. So we'll get, define a function, get taxes at tackets. Oh my goodness, taxes at what? Eric said something and someone else showed up on the screen. Yeah, it's a it's been a day. All right, so we need the start of the bracket. We need the end of the bracket of bracket, or top of the bracket, right? And we need the tax rate. Okay? And then we need their income as well, right? The adjusted gross income and adjusted gross income. And again, we could put those in any order we want here, but that's fine here. So if the adjusted gross income is less than the start of the bracket, we're going to return 0, right? You owe nothing at that bracket level. Right? If it is more than the end of the bracket, you owe all of it, right? So if the adjusted gross income is more than the end of the bracket, we can return. Now, make sure we do our order of operations here, because I forget that all the time here. The end of the bracket minus the start of the bracket times the rate, right? Take the end of the bracket, subtract the start, multiply by the rate. Right? That's what we were doing here. So at this rate here, 48,000, you've already paid taxes on the first 11,900, so take that part off, 12% of the rest, right? And then if it wasn't that one, then we can return. Again, we don't need the else's, they're redundant at this point, because once you hit a return, you're done, right? So if that's not true, if you're not less than the start, you're not more than the max, we're going to take the max minus your income here, your adjusted gross income times the rate, right? No, sorry, that's the other way around here. So your income minus the start. There we go. It's going to do the wrong thing here. So whatever up to you already pay taxes at this rate here, right? So say your income was 50,000, right? You paid all of it at this rate here. You're only going to pay 50,000 minus 48,475 at the 22% rate. So that's only what, 1,500 bucks at the 22% rate, right? Because you already pay taxes on the first amount at this rate and the taxes on that at that rate here. And as we work our way on up, then sure, we are going to owe 0 and 0 and 0 and 0. Okay, so money out of their tax brackets, then we can say for, I don't know, index in range, the length of my bracket rates. It doesn't really matter which one we pick here, right? We're going to take our money owed at the tax brackets and we're going to append the value we get back from our get taxes at the bracket given my start of bracket here at the index, right? The end of brackets at the index, the rates, bracket rates at the index, and the adjusted gross income. That's a little long here, so we can bump that down one. It gets a little bit ugly here, sorry. Wow, sure, that sort of fits on my screen. Again, I'm zoomed in a lot, so whatever your preference is here. Right, and we just do that every time. We multiply and multiply and multiply and do the arithmetic. It's the same arithmetic every time, right? And then now we have our money owed at the brackets, right? Okay, so then we're going to go display it, right? And then we'll show the total taxes owed and then some other arithmetic, right? So for rate in bracket rates here, we can print a nice formatted string here, right? This is taxes owed at, now to get the percentage, right, we can take our rate times 100, right, and stick in a percent sign here. Probably get us the right number, right, 12%, 22%, that sort of thing here. A colon, and then that'll be the, oh, we need the index, shoot, don't we? We need an index, sorry. That's a bummer. Bracket rates at the index in range of the length of the bracket rates here. And then we can throw in our money owed to the brackets, right, at the index, right, because that should match the 10% bracket. It should be the first index, and that's the first thing we appended here, so it should match. And we're just taking advantage of these being kind of in parallel here as we go. Let me bump that down a line. And then maybe throw in a dollar sign here because that'll look nice. And if you want to do the formatting, right, it's the 0.2f, but we shouldn't have any decimal places, so it probably isn't going to matter here. You might have, I forget, I don't know if they charge pennies or not, but it's probably okay. If it looks ugly, we'll go fix it, but it's probably okay like that, right? And then we're going to print the total taxes owed, again, as a formatted string. So total taxes owed is a dollar sign, and then we can just say, hey, I want the sum of the money owed to the brackets. right? Sum's a built-in function in Python. We'll sum up all the values in a list. It's a nice handy one here, right? And then we're going to print uh, taxes owed as percentage of gross income. All right, now I'm going to feel bad because we have to do the sum thing more than once here. So maybe we'll make that a variable. So total taxes is this number here. So we're going to use that more than once. So we might as well call it total taxes. Right, so that is my total taxes divided by the gross income, right? And then if that's a percentage, probably multiply that by 100 and stick in a percent sign, right? So if we owed $1,000 in taxes and we made $10,000, we get 10%, right? I think that comes out right. And then we'll do that for adjusted gross income. Adjusted gross income. Right? I think that ought to do it. Right? I forgot to hit run earlier, so we'll see if this works out here. Um, oh, it doesn't like sum because we already have something named sum. It's probably going to be fine here. We should call that total then, I guess. So let's go rename to total. There we go. That's a little prettier. Just make sure I get rid of all my yellow lines because they bother me here. All right, let's give it a run. So enter deduction. Hey, here's $1,000 deduction. Do we have more to enter? Yes. Let's deduct $10,000. Yes, we have more to enter. Let's deduct another $10,000. Do we have more to enter? Yes, sure. Let's do another 10,000. So that should be 30,000, 31,000, right? No more to enter. So that should get us at above the standard. Sure, why not? Enter income. Let's do 100,000. And then we'll say, yes, we have more to enter. Let's do like 25,000. So 125,000. No, I never spit out the actual gross income, but that's okay. All right, yep, it seems like it rounded okay so far. So 10% of the total looks right here. 12% of the total, probably the right number. We could go calculate that, right, if we wanted real quick. What's the 48,000, 48,475 minus 11,925 times 0.12, 4386. 4386, all right, that one checked out here. And then the 22%, oh, this one should have commas in there, so we should do a little formatting. We can add our commas if we want. That's in our taxes owed here, right? That is money owed should be a colon, comma. I think we'll add in that. I think that's right. 0.2f, right? For two decimal places and a floating point number, that's probably fine. All right, so let's see if the 10,000 checks out here. So if our income was 110,000 minus the 31,000, right, for the adjusted gross income, minus 31,000, or for deductions was 79, right? Take that minus the 48,475, 475, multiply that by 0.22, 6715. That number's not the same. Let's see, did I do the brackets right? Maybe I put the numbers in wrong. Forgot to enter all the right deductions. Oh no, 125,000. Did I do that wrong? I did. So there's 125,000 minus the 31,000, right? Times minus the 48,475 times 0.22. There we go. The number checks out, right? If we don't know what we're supposed to get, we're going to have a really hard time checking to see if the code worked, right? So we need to be able to work it out by hand or with a calculator, right? Do all those numbers make sense? I'm just kind of shouting numbers here. Reminds me of my old scoutmaster. She was a CPA, and during tax season, she'd bring all this stuff, and she would just fly on the calculator. It was ridiculous. Like, wouldn't even look at it. She's just going down this like to check people's work. That's crazy. All right, and then 12% here, and okay, so these ones probably we should round as well, make those look a little bit nicer with the 0.2f's. And then sure, why not the digit separator? No, we're not going to need that for percentages, right? Just the 0.2f here. All right, we'll clean that up a little bit here. So 0 deduction, no, and then 100,000. We should be able to get the standard deduction. Say we're done. Oh goodness, I put it in the wrong spot here. Where did I? Oh, yep, that doesn't go there. That goes here, colon. There we go. Yep. Okay. Let me try that one more time here. Make it not look quite so terrible. No. Hey, that looks a little bit nicer, right? Yeah, digit separator, pennies, looks pretty good. Total tax. All right, close enough, right? Total taxes, colon. I think just the comma ought to add the digit separator for us. Feel like that'll work. Let's try it and see. There were no points for making it look pretty, right? Oops, invalid number. Let's see if we're gonna enter. Oh, look at that. Our error checking even worked. Forgot to check that. There we go. Now we get the digit separator. Life is pretty good. Looks pretty happy. Should we try like a really big number? Make sure it works all the way through? Yeah, of course. Sure. No. Right. And we pretty much hit 37%. Right. I think that was a rounding error if you're at a billion at that point. Now, the funny fact here, no one ever earns $1 billion in earned income because most of their income comes from capital gains, which is not taxed at the same rate as earned income is because it doesn't show up on a W-2. There's another fun fact that thanks to the billionaires and millionaires who write our tax code. Of course, they wouldn't want the bulk of their income to show up as be taxed for the income tax at the 37% rate. Sorry. Definitely don't care way too much about this. um, but now we learned some cool programming stuff and we learned some cool stuff about taxes and economics, right? Yeah, it's really cool. Economics was definitely my favorite elective I ever took. Super interesting, really cool stuff here. And it turned out to be really sad because like all the math that went into it was like people don't actually behave like machines. And then the guy who won the Nobel Prize for economics was like behavioral economics. People are irrational and they'll do dumb things against their interest if the math is bad because they really want to. They're like, ooh, this is true. We didn't know people were stupid already. But now there's behavioral economics is the new hot thing in economics. So, all right, very exciting. Let's go commit that to GitHub. Yeah, that's a good one. Yep, yep. Years ago, because it's an old book now, my goodness, when I was in school, the hot book was The World is Flat, talking about how globalization enables all sorts of things. And like Dell was the case study, how you could order a custom PC and get it 3 days later, like shipped around the world. Um, and now some people think globalization is a bad thing. And I'm like, I don't understand, but that's okay. Project One. I work with a econ prof. She's got her PhD and she's really smart and nice. And I asked her one time, like, when I went to school, they said tariffs raise prices and it's a tax. And she's like, please don't get me started. I'm just going to get angry. Uh, so if you ever want to see your econ profs get upset, just go ask them about tariffs and be like, hurt is not a tax. And then they'll just turn red in the face right away. It's really funny. Um, I don't encourage you to annoy people on purpose. That was a bit of a joke, right? Um, all right, let's move on to files. So let me start up a new project here. New project. What week is it? Is this week 4, week 3? We're like halfway through a week, right? Because we started early, or week 4? Files. All right, I'll call it week 4. We'll probably be fine here, right? We can name things any way we want. Thinking about it. Did you guys ever hear about rubber duck debugging? Is that a term that came up yet? Yeah, yeah. Debugging. It's a fantastic tool here. Um, you just explain what's supposed to happen to your rubber duck. You don't even have to bother your senior developer. Just explain it to your rubber duck, and by explaining it, you'll probably find your bug. Because as you're looking through your code, you'll realize the thing I'm saying isn't the thing I wrote here. And I feel like I'm doing that as I'm coding live in front of you guys, making mistakes and doing things. So, um, but you guys are not inanimate objects. You're real people. But there's also, I don't know if I showed you this one here. There is CS50.ai. Did I show you this tool yet? This one's really cool. So the fine folks at Harvard, I believe, run this massive CS50 course. It's like an intro to CS here, and they came up with this designed for students here, and teachers I don't really get, but that's okay. Designed for students, really. Um, and oh, Yale, not Harvard. Sorry, I probably offended somebody. Hmm? They like did a joint thing at one point here. I don't know how it works here. But The goal of this one here is the way they've designed it is to act like a tutor rather than just giving you answers here, right? So if you be like, hey, how do I do this here? It's how write Python code to do this. Oh, too much text. Uh-oh. That's pretty close here. Good enough. Too much. Okay, get rid of some of this one here. All right, Python code. This is like the smallest little prompt here. No wonder. Well, it's designed to ask you like succinct questions, right? Repository. Yeah, okay, get rid of that one. Oh, goodness. Oh, I didn't do my screenshot, sorry. Um, you all okay with the screenshot process? Yeah. Hey, that worked. Could you tell me more about your current progress or specific questions you have? Right? Like, it's not going to just give you the answer, which is nice. So this was designed for students to go and ask. Essentially, we're going to try and get rid of grad students at these big universities who actually teach the classes and answer all the questions. Like, don't ask a real person, just ask the robot. Sure. I'm sure our grad student union has things to say about this, but that's a whole other subject. But anyway, you can do the same sort of thing with the other chat tools. Just the first prompt you give it is pretend you're a tutor and don't give me answers. And then when you ask it questions, it pretends like it's a tutor and doesn't give you answers, right? So I don't know, like, how do I loop through text brackets? Yeah, this like heart here, you only get so many hearts and they refill over time. I forget what the speed is on it here. Like, oh, hey, you could start in a list or dictionary. For example, you could have a list of tuples, right? Then you could iterate over this list. How do I make list? Look at that. Okay, finally, so like 3 questions in, it finally gives you a little bit of Python code. But again, it gives you little bits. So feel free to experiment with this sort of thing. Again, um, you could do the same thing with the other tools, just giving it the specific prompts first. But this one's kind of fun and was designed by their CS people to be good at doing CS stuff and giving hints and help like that. So you've probably noticed the effectiveness of the tools varies widely. Right, the different tools are wildly good at some things and bad at other things, and it's a little crazy how different they all are. So just keep that in your back pocket if you want it. That's a fun one.
Sorry, if we use this, do we need it? If we're not like actually using the code from there, would we still need to cite it if we're asking any questions with all
So if you're turning in something that's not yours, you would cite it. Right? If the only thing you've ever gotten is English out of it, perfectly fine. No need to cite anything. If you're taking code, copy pasting, or like paraphrasing the code itself, then a citation is would be needed. Yep, and you would just drop in a link here, and be like, "Where's my welcome file?" And, you know, how do I, right? Something like that, right? Just tell me what the prompt was, because otherwise I don't see the prompt. Is all. Yep, and that'd be great. All right. So working with files, there's built-in ways of opening files here. We don't need to add a bunch of other libraries, add a bunch of imports, and do some crazy things here. It works out pretty quickly for us. Now, you can do relative file paths, which is what we're going to do pretty much all the time, or you can do the absolute file paths like, hey, C:/user/eric/document/ what it gets really long, and then it's not portable because it's a full path here, and no one else has an Eric directory on their computer unless you also happen to be named Eric, right? So pretty much everything we do in Python will be relative files because we say relative to where my program is running, please go look for this file. So if you're the kind of person who likes to do this stuff by hand, the directory which you launch Python in is the relative directory. So if we just say, hey, I want to say my file reader is open of test.txt and file reader. Now you can read, which will give you everything in a single blob, text blob, string. You can read line, which will give you one line and then leave the reader open. So then you can read the next line and read the next line. Or you can read lines, which gives you all of the text, but in a list of strings, one line at a time. Whichever of these you'd like to do, read lines is usually easiest for relatively smallish files. Right? If you have a really, really, really large file, you might not want to read it all. I mean, we have decent amount of memory. I can read, several meg files. Probably, I could probably even read a gig size file without too much trouble. And you probably don't have that many really large text files on your computer. So we're probably fine. But as we start looking at if we wanted to do data crunching on millions of pieces of information in a data set, don't read them all in, right? Do it one line at a time, do your data crunching, whatever you need to do, and then move on. But for most of our purposes, read lines should be fine here. We'll say read lines. So here's the, I don't know, contents is read lines. And then for line in contents, we're just going to print the line. Again, not very exciting. We're just going to print out what's here. But right now, when I try and run this, it crashes. Hey, no such file or directory exists. There is no test.txt here. Um, and in our Python code, right, what we're running here is from this directory. Right? This is the working directory here, so it's expecting a file relative to this folder. That's what PyCharm is doing for us. So when we go to run our project, it runs it in that folder. Right? You don't have to run Python files in that folder. You could start your Python file like from C:, or from your desktop, or wherever you wanted to do that here. You could run Python from there, and then it won't find the file with the relative path. So you have to be a little bit careful when we're dealing with files and pathing here. But I can just go add a new, this is test.txt file here, and we'll say, happy Wednesday, it's cold outside. New project, yay, right? And I'll just do one more new line here just for fun. So it's 4 lines, right? We can see all that. And now when I run it here, it doesn't crash on me. It works, but I get some extra new lines here. Or the new line character itself is a character at the end of lines. So when I get the read lines, the individual line has a new line at the end of it. And when I call print, print also adds a new line at the end of it here. So if you don't want the extra new lines here, you say, hey, Python, please change the end of your print here to just a nothing, right? You can really put anything you want here, but by the default is a new line character. So I'm saying, please don't use the default new line character, just do this, right? And now we've read the file, we read the contents. I'm a little bit naughty here because I forgot to close the file. When Python ends, the file gets closed, but it's good practice. Anytime you open a file, right? You open it, you read or write it, and then you close it. You want to explicitly close it so you don't leave that open in case you want to do something with that file later, or it's a long running Python process or whatever happens here. So we'll say file reader.close. So this is open, opens the file, reads the file, closes the file. That was pretty self-explanatory, I hope. It does the exact same thing, but this is better practice. So in case I'm doing lots of other Python stuff, just don't leave the file open, right?
When you going to say which line is on, so like Happy Wednesday, line one, blah, blah, blah,
Yeah, so if we wanted, we could get the index, right, for the length of range over the length of the contents, right? And then that index serves as our line number, right? So then we would print formatted string, goodness, that one here, line number, oops, line number, and then we would put the index in here, right? And then maybe colon, and then we could put in the contents at the index, right? And that should tell me the line numbers, right? So line 0, line 1, line 2. Or if you wanted to say line 1, right, just add 1 yourself here, right? Do your arithmetic. That sort of what you're looking for with line numbers? Yep. Cool. Notice that we have a line 4, but it doesn't get read here because it's like dividing things by new lines. So essentially it's split here. And then there's just nothing on that line. But if you have a space on that line here, then I run it. Oh, no, it also, oh, I didn't save my space. Maybe I didn't actually hit save. Does it now exist? No, nothing. It's not saving the space. Something's weird with my file here, but that's okay. Right? It's not the end of the world. So reading text files goes really quick. Now, if you want to write a text file here, we'll call this the file writer, is open. Given, let's give it a different name here. How about output.txt? Remember, the .txt is purely optional. It's recommended here. The computer doesn't care if the file has an extension or not. It will read and write it like a text file. We add the .txt so your operating system and your tools know, hey, it's a text file, right? Completely optional, just a good practice to have in here. The file types here, the extensions, determine what program your computer wants to use to open it with by default. But it will still give you a text file if it is not a txt. You can even name it something like .class. I wouldn't recommend that here, but anything you want here, you can put in nonsense if you want. We'll call it .wednesday. Why not? right? Then we take our file writer and we say write. Now you can write or you can write lines. So write lines, you give it a list and it will write the list of lines, or write will just write that individual line here. Now with write here, we'll say happy Wednesday, and then let's write, are we done yet? Right? And then we'll close it here, not close, right? Open the file, write the file, close the file here. Uh-oh, no such file directory, output.wednesday. Now, when I called open here, I didn't tell it I wanted to write the file. So open has a couple options here that you can give it. What do we want to do with this file here, right? Sorry, sugar's a little high. All right. So if you want to write the file, you tell it, hey, let's open the file for writing, please. Now, there's a bunch of different options here. Don't worry too much about them. We can go Google them here. Write for appending is the plus, right? Write B writes a binary file in binary format rather than text format. Excuse me. I don't even know what some of these other ones are here. I would just have to go Google them because I don't remember. So open the file for writing, and now it says nothing. There's no crash. There's no indication anything worked here. Now we see there's another file showed up because PyCharm is like, oh, hey, something's in the directory here, and it's a text file. I can open it, but there's no new lines. When you write here, you have to add in your own new line characters, right? So add in your own new lines like that, right? So make sure you add new lines manually here, otherwise it doesn't know to go down. And now when I run it again and check it Wednesday, notice the file has been blown away and overwritten. So writing by default, like you're used to in C++, means it blows the file away, right? So this will truncate the file if it exists or create it, right? So if it exists, it gets blown away, you lose all the contents. If it doesn't exist, it will make the file silently, right? There's no error. It's not like this file doesn't exist. It'll just make the file for you. So it's pretty friendly, but just be careful. It will erase whatever's there. So don't target important system files, right? When you run your Python code, that's probably a good habit. All right. So reading and writing basic text files works really easy, right? Other fun things we can do then, excuse me, is we can use the JSON format. I don't know if you've had a chance to run into this one here. The JavaScript object notation. I don't know why someone come up with that, but sure, JavaScript object notation. This is a super common way of storing data and transferring data. It essentially gives you a dictionary, a key value pair. Right? Here's a key, here's the associated value. Here's a key, here's the associated value. And it works really quickly in Python. So we want Python, JSON, read and write. Look at that. So you want to open a file and then you call dump. JSON dump, here's the data here. We'll go and write that file for us here. Don't worry too much about the Unicode stuff. It should be okay. And then that will go and write it. I mean, we want to read a file. Does it not give me the reading example? That's okay. So the JSON library is what we're going to import here. This is a built-in one in Python for us. So we're going to import JSON here. Let's just go steal this example here, right? And we'll go cite our source here. This was, come on, Bing, Python. Okay. So this is a dictionary. Here's the key. Here's the associated value. Here's the key. Here's the associated value. Here's the key. Here's the associated value, which also happens to be a list. That's okay too, right? You can make associated values of lots of different things here, which is fun. Then writing it to a file, right? We're gonna now the with. What this lets us do is automatically closes it when we're done. So with, we'll open it, calling it f, right? And then we can say f dot whatever we want here. Now we don't say f dot write. We say JSON dump to the writable file here. Okay? And f is a terrible variable name here, so we'll call that just file here. I think that's a little bit nicer. The indent here will automatically add indentation, so it looks nicer. That one's optional. Should be okay either way. And we're going to open the file for writing. Again, it's a JSON file. Let's dump some data here. Give that one a run here. We get data.json. We open that one up, and it looks exactly like the dictionary here because it actually is a dictionary, right? What JSON files are dictionaries. That's all they are with these curly brace notations. Again, we'll get to that next week, play more with those as we go. But name, key, and the associated value, key and the associated value, right? Key, associated value. So the types here, right? It knows it's an integer. It just is an integer, right? These other things are strings. It knows it's a string. So if you wanted to get the data back out here, then here's the data from file. Um, so we need to go open, hang on, we go open the file. So we'll say with open data.json. Now I don't need to open it for writing here, right? We'll call this as file, JSON file to read. I don't know. I like long names here. That's fine. We say JSON dot reads. Oh, JSON dot load. There we go. JSON dot load. And load says, all right, what are we going to load here? Let's load from the file here. And where do we want to put it? Right? Is that the right direction? Loads and the object. Oh man. Hang on, I got to remember JSON dot load the file. Just returns the file loaded. Loaded data, read JSON. Yeah, okay. So there's my data from file is JSON.load given the file. No other arguments needed here. Great. And then we're done. It closes the file for us here, and we're just going to say print the data from the file. Here, just print it out, see what that looks like. Oh, goodness. Oh, it tried it on a closed file. What do we do here? Oh, sorry, not the file here. This is the JSON file to read. That's what happens when I copy paste and rename stuff. There we go. And we get out a dictionary, right? It doesn't have all the nice pretty formatting, right? We don't have all the tabs and things like that, but that's okay. It's stored in Python here, and we can do all the things we want in Python with this. So JSON files work really nicely for us for storing information. Now, it doesn't have to just be a dictionary though, right? We can add other stuff to this here, which can be fun. So if we just want to give it, let's try another one here. Um, let's make a list of foods because I'm hungry. What are your favorite foods? Pizza, pasta, burgers, tacos. All right, that's a pretty good list here. Now let's try and write that here. This is food.json. We're going to dump our foods to the file. Now here's my foods.json. It is just a list, right? It doesn't have to be that dictionary notation here. It can be other built-in Python types, and they'll JSONify pretty nicely here. Now, generally, you just want one thing that you're dumping in there, because otherwise reading it's going to get pretty hard. So just having a single list might not be the most interesting thing in the world, but we've got lots of fun options here doing it that way. Right, and the other thing I wanted to show you was CSV. There's a built-in CSV library if you like comma-separated values. That's essentially Excel files, but not fancy, just the basic ones that are just separated with commas. Okay. I don't ever recommend you do this by hand because CSV files get to be really gross as soon as you start having apostrophes and quotes and other weird things inside of it, right? And doing that by hand is awful. So essentially just a CSV file here. Let's go make a new file here real quick. Let's call this test.csv here. Look at that. It even wants to be a fan. Oh my goodness. There's like a CSV editor. What is this? I don't want that. I just want it to be a text file. Oh dear. No text. There we go. Then I want the text button. I found it. There's a button for that. All right. So let's have like name and age and number here, right? You guys know sports ball people, right? Right. So give me a sports ball person. LeBron James. I know that part. How old is he? 41. What's his number? Number six? What? 23? All right. Give me another sports baller. Kobe Bryant, right? How old's Kobe? Oh, yep. Sorry. My bad. I remember that. And what was his number? 24. Okay. One more. Tom Brady. All right. Well, sure. All right, good enough. So you have a bunch of values separated with commas. That's a CSV file. It's comma separated values. Now we could open this in Excel. It's just probably easier to make it this way here. But yeah, for fun, let's go open it with Excel. I'll show you that works. So if I want to open in Explorer, I can take this CSV file, and my computer even knows, hey, it's a CSV file. Do you want to open it in Excel? Again, that's what the extensions are for here. So I can double click and it should open in Excel, and I get an Excel file. Right? That's all it is. Now, Excel itself will save files in a binary format with the specific Excel formatting, not CSVs. You have to ask for CSVs specifically. That's okay, right? Not the end of the world here. So anyway, if we want to go read this file here, we're going to import the CSV library here. And then to go read our file, it's a little bit weird here. So we'll say, here's my CSV file is open. This is test.csv for reading, and I'm going to say csv.reader, given the CSV file here. Here's my CSV reader. Is this one here? And then with the CSV reader dot, right? Now I can do all the things here. Right? Is that get line number? Goodness, I have to go Google it again here. For reader and row. Okay, just prints out the row here. Okay, great. Sure. For row and reader. So just right away, that gives us the iterable object here. So you just iterate over that here, and it will manage all those line numbers for you here, right? So each row is a list then, right? The top row, so row 0 is the first one, row 1, row 2, row 3, that all works great here, right? Now, you'd think we could just read it in as a text file and split on commas. That works out great here, unless you start doing dumb things like, hey, let's put the character or the player's names backwards. And I'm not going to do it in Excel because it will auto format it nicely for me. So instead of LeBron James, we'll say James, comma LeBron, right? And Bryant, comma Kobe, and Brady, comma Tom, right? And I want to save that as a CSV file. Now, what happens as a CSV file? Where does that go? Here, they get quoted because there's a comma inside of it here, so it has to go look for quotes, right? Now, if I was just looking for commas and splitting my strings on commas, where we looked at string split here, that's not going to work, right? We'd have to like look for quotes and then take the quotes out and then split or ignore the commas that are inside a quote. Like, I don't even want to try that. That doesn't sound like fun, right? I'm sure it's doable, but our CSV reader is like, oh, sure, great, here you go. Here is one item from that cell, right? And it handles it for you. So we don't have to do any of that hard stuff here. Okay, so CSV reading, really easy, and then CSV writing also goes out really well here. So if we wanted to take our favorite foods and write that to a CSV file instead of a JSON file, we'll make a CSV writer equals open, that's foods.csv, open that for writing here, that's a W in strings here. So we've opened the file, csv.write, writer given the CSV, oh, sorry, the CSV file here, given the file. So now we have CSV writer is that one here, and now CSV writer dot. You can write an individual row here, which is a list of values that you would give it, or write rows, right? Give it all of the rows that you want it to write here. So we'll just say all the rows I want to write is foods here. Okay, and then we're done. CSV writer dot close. Oh no, CSV file dot close. There we go. Make sure we close the file. I forgot to do that earlier here. CSV file dot close. Again, the open syntax is really nice, so you don't, or the with syntax, so you don't have to remember to close. Right? That's pretty nice here. I just forget to use it. So now we should have a foods.csv file. Uh-oh. That didn't turn out exactly what we wanted here. Let's see. So the foods list here, right? It thought this was the list of lists here, right? So probably we need to do this a little different here then. So we'll say for food in foods, CSV writer dot write a row of the food here. Let's try that. So we write out in a single row here. See our foods.csv. No, didn't we fix that? Hang on, run it again. I feel like that's not right. Hang on, let me just try and delete it here. Refactor anyway, delete, and run. No, still doing it for us. Oh shoot. Okay. Let's see. What did I do wrong here for writing? That's writing the file. Right row. You have to give it something specific? Hmm. Feel like that should have worked here. That's sad. Maybe we'll make a list here with the food in it. Because strings look like lists, so it's turning each one of the letters into an item to put in the list here, and that's confusing it, I think. That might do it here. Let's try. Hey, okay, so now we have that here, but we're getting extra new lines here. We don't want the new lines to show up here. So let's take our food and we'll call the strip on it here to remove the white spaces here. Let's try that. So now let's take our foods.csv, still there, writing, right row, food dots. Can I just add it in here? Strip? No. Hmm. Why are we getting extra new lines? I don't remember. We're getting a bunch of them too. We don't have, it's just the list there. It should have taken them off. Right row, within the row. Right row, right row. Not sure why we're getting it. That's okay. That's not super important. We can go back to that. I don't want to take up too much of your time. It's probably a quick Google. Should we just let's just ask here. Let's try it here. Let's go to the UMGPT tool. See if it has an answer for us instead of just Google. It's very exciting stuff, right? It's thrilling. Am I getting new lines in the CSV output file? See if we can figure it out for us here. Pro tip, use with. Haha, there we go. Setting new line to blank when we open here. Allows them to eliminate the extra new lines here. So with the new, did I just miss that in the example here? I probably did, didn't I? Yep, sure did miss it. You guys didn't let me cheat the right way here. There we go, setting new lines to blank. So it looks like when you write it, it's giving us new lines? That's interesting because we had to add our new lines before. Maybe because it's CSV. Might be special with CSV. New line is blank. All right, now let's try it here. Food CSV. Hey, all right, that one worked here. So maybe we don't need to strip that lines. Let's try one more time here, see if that works for us. All right, sweet. So that was in the Bing and ChatGPT, UMGPT. What do we search for that one? Python CSV. All right, so that new line is important. So we can read CSVs, we can write CSVs, we can read text files, we can write text files, we can read JSON files, we can write JSON files, all sorts of fun files. Right? Reading and writing is fantastic. Feel pretty okay? You know, nothing new and groundbreaking. Binary files exist. You can play with them if you want. At this point, it's not really worth our time. Later, you can do something fun with them if you want. Should we talk about the next project? All right. So, project two, also finance-based, because those are interesting to me. Let me go publish this one here. We are going to build a retirement estimator for people here. If this one loads here. So new classroom link. Hopefully it works. I did hear one of my friends was looking it up here, and they think you not getting added automatically to the repository happens if you don't have two-factor authentication added to your account. You would have to go manually find the invite and accept it. Just sure, either way is perfectly fine. It probably sends you an email. If you don't find that, don't see it in your list, don't see it in your GitHub notifications, ask me. I'll get you in. We'll get you up and running. And a new repository just to keep things clean and separate should work out pretty well. And I found out I don't get a grader for the course. Long story with the other class I'm teaching. So I have to go and grade the stuff manually. My apologies. So I'll get to that now that I found out I don't have someone to help, which is sad, but that's okay. Not the end of the world. So turn the URL of your project, add a screenshot of it running, and the self-assessment. Right, pretty normal there. So we've got a file for you to read, a bonds and stocks annual returns. So what we're going to do is we're going to make 4 overly broad categories of places to store your money. Again, over broad generalization here. It's just an estimator here. So 4 places you can put money here. You can put money under your mattress. You get no rate, no return on investment. The money's just under your mattress. It does not grow magically. There is no tooth fairy who adds money to it, right? It just stays there. Money in bank savings, we're going to assume a very generous 2% rate here, which is way larger than you'll get from any bank savings account. But again, just pretend with me, okay? It's all right to have some fantasy here. The bonds investment is just a generic, we'll call it bonds here. I pulled them rates from the Treasury bonds, I believe it was here. So this one does vary. Generally is always positive for bond returns because lots of reasons here, but lower returns than stock market. Okay? And the stock market here, I have again from the file here, is the historical returns from the S&P 500, which vary wildly. Some years it goes up a lot, some years it goes down a lot. Right? That's what happens in investing in stocks. Right? So what we're going to do is we're going to ask the user how old they are and how old do they want to be when they retire. And we're going to figure out how much money they'll have by the time they retire and have saved up for it. So for every year until they retire, ask them, do you want us to put more money into your accounts? Yes, sure. And then they can put money into one of the accounts, 2 of the accounts, 3 of the accounts, 4 of the accounts, put money into the same account over and over and over. Just let them enter something here, right? And until they're done, right? Like 1 for this account, 2 for this account, 3 for this account, 4 for this account, 5, just go to the next year. Something like that, right? However you want to build out your menu, perfectly fine. Menus are boring, right? And then we'll apply the yearly rate of return to the accounts. The money in your mattress has no rate of return. Money in bank savings will pretend grows 2%. The money in bonds grows the bonds rate here that we read from the file, stock rate from the file, right? Print out the balances of each account and a total of all of the accounts, right? So, okay, so at the end of the year, this is how much you have under in these 4, right? And your total, right? Um, and we're going to print just the yearly account balances and a total to a CSV file. So we want, here's your mattress money, your savings money, your bonds money, your stocks money, here's a total. Right? We could calculate the total, but we're going to put in the CSV, makes it easier to graph without having to do arithmetic, sorts of things here, right? And then after they reach retirement age, print the totals for each account, their total retirement savings, and then we're going to do the SAT part here and adjust the balance for inflation. Right? Thanks to inflation, your purchasing power goes down every year because things get more expensive. So having $1,000,000 today can purchase many more goods than $1,000,000 30 years from now will purchase. Right? 40 years from now, 50 years from now, right? By the time you retire in your 70s, right? Because they're going to keep raising the age here, right? Purchasing power will go down. So this will adjust for that. We're just going to assume a fixed 2% inflation. Again, this is magical and pretend. It doesn't actually happen here, and inflation is way higher than 2%. But the Fed Reserve aims for a target 2% inflation rate here. That's the goal. And of course, everything we aim for, we achieve. Something like that, right? We're just pretending here. So essentially, money in the bank savings earning 2% after the 2% inflation never grows. You don't have more purchasing power, but you've maintained your purchasing power. Right. So if you put $1,000,000 in a bank savings account and get 2% interest with 2% inflation, after 50 years, you'll still be able to buy $1,000,000 worth of products. Right. That's sort of how that works here, right? Even though you'll have many more millions in the account after 50 years. All right. So the file itself is a little ugly on purpose. There are percent signs in the CSV file here. Right? If you try and read in 43.81%, Python will puke on you. Right? That is not a floating point number here. So you have to do a little bit of extra work. That was intentional here, right? When you read your file, right? The input's not so pretty. And then this one here is in percentages here, right? With the whole numbers and everything. This one is also percentages, but it can go negatives. This one can go negatives. So probably the easiest way to go about it here is to just pretend this is year 0 here and on up. That's not quite realistic here. History doesn't repeat itself. You could also just pick one randomly if you wanted. That's perfectly fine too. As long as you're getting one of these values out here for every year, I'm happy. Right? If you want it to be random, if you want it to be sequential, if you want it to be reverse order, if you want to be in order, I don't care. Right? It's just this was in a file I downloaded from someone's website here. It had the year number and the actual historical returns. So you can see some years are bad in the market here, and some years are really good. Like a bunch of years of 20 to 30% here. This was a hot time in the market, right? and then it went down a bunch, and then it went back up a bunch, and then 2008 happened and went down a bunch here. That was a bad year to retire, by the way. And then, that was a good year to buy a house, though. Really good year to buy a house. Sorry to all the people who lost their houses. So the problem you all have, right? The mistake you made was not buying a house 20 years ago. That's your problem here. If you would have just bought a house 20 years ago, you'd be fine, right? Obviously. Yeah, you should have taken it. You had your shot and you missed it. So, big mistake on your part. All right. Um, that part makes sense, right? So again, just a little practice reading and writing files here. We haven't got to graphing in Python yet, but if you write it to a CSV file, you can open it up in Excel and hit graph, and it will give you a pretty looking graph here. That's kind of fun to show people as well. So those sorts of things here. Okay? Questions, thoughts, concerns? All right. We will meet on Monday for the first time ever. We do have a Monday meeting here, surprisingly. So Monday, 11 o'clock, we should be here, and we'll go from there. Thanks, everybody.